to take a look at some special right triangles. And we're going to start this by talking about a 45-45 triangle, which means it's isosceles. If we have an isosceles triangle, we get a special right triangle that comes up, and this is very common for them to want to use as a sort of testing system. If this leg's length is side x, and this leg's length is side x, then the hypotenuse is going to be x times the square root of 2 as an answer. So using our Pythagorean theorem, a squared plus b squared equals c squared with a right triangle, if I know a leg length, I can figure out all length of the sides, which will allow me to use my ratios in order to figure out anything that's left. But we're going to use these frequently enough that it's not going to be such a big deal. Another very common right triangle for us to use would be a 30, 60, 90 right triangle. Now across from 30 degrees, the shortest leg of that triangle is the leg we're going to talk about having an unknown length of x. The 60 degree side, side A here, the 60 degree side of that triangle, its side length is going to be x square root of 3, and the hypotenuse length is going to be 2 times x. Now these are very common triangles for us to have to be able to use in these ratios, and getting used to being able to use between them will be incredibly useful later on. But there are some Pythagorean triples, some of those given a right triangle, then a squared plus b squared is equal to c squared when c is the hypotenuse. There's some very common triples that we would have to use. One of them would be 3, 4, 5. Now the 3, 4, 5 side would also include 6, 8, and 10, or 9, 12, and 15. Any multiple of that, when simplified, is the 3, 4, 5 triangle. Another very common one that we would use would be 5, 12, 13. We would get 7, 24, and 25. We would get 8, 15, and 17. Now this is not all of the Pythagorean triples, but these are the most common ones for you to come across, especially on these Common Core testing. So the big thing to take here is you can test these out using the triangle ratios from the previous video to go ahead and find your sines of angles and your tangents of angles, or your tan inverse to find the angle on a right triangle that's isosceles, to see that this comes out on a right triangle that's a 30, 60, 90 triangle, and to try with any of these Pythagorean triples. This is being done just to sort of really shorten up this bit, but you can do it entirely through exploration. Remember, math rocks with a capital M.